This is an animation showing the squeeze theorem. So what we have here is this blue function, and the blue function is x times sine 1 over x plus cos 1 over x. And we want to know what happens as it goes to 0. So this 1 over sine 1 over x as it goes to 0 is problematic because we don't really know what's happening. This is kind of going to infinity, and it's really messy looking. Same with the cosine. It's going to be going to the angle is going to infinity. It's really messy. But what we're going to do is we're going to bound this blue function with the pink function here, which is I think 2x. And we also have this yellow function or orange function that is negative 2x. And we know that for all values, the blue function is always between those two values. And what happens then is, as we move that point closer and closer to 0, we can see that although the blue function goes up and down, what ends up happening is it's bounded by the upper-lower function, and it gets squeezed towards 0. So we end up getting this limit as being 0 because it all gets squeezed to 0 by the upper and lower function. We can do it from the left-hand side as well. We can see that as we go from left to right, it's being squeezed. Although it's going up and down, it's getting squeezed between 2x and negative 2x. And as we hit 0, the 2x and negative 2x come together at 0. That means that whatever's happening in here, we know that that's going to end up at 0. So this is an example of the squeeze theorem.